welcome to Ladyada. Happy
Hey,
2024.
I know. Happy New Year, everybody. It's me, Lady Ada, with me, Mr. Lady Ada, on camera control and background humor and the laugh track. Okay, so Happy New Year. I thank you for your patience. We took a couple weeks off. The holiday season, just trying to chill and get rejuvenated. But break time's over. We're back. And so welcome to Disco Ladyada. Okay, so let's go to the computer and we'll see what we're up to. Okay, so I'm still doing this massive redesign project, which Mr. Ladyada has had to listen to me rant about for like almost a year and a half now. I started like, I think, September. No, earlier than September. It must have been like August, a year and a half ago. So it's been quite a while. But basically going through every single product and revising it because enough components got discontinued or changed. Then I was like, I have to go when going through and sweeping everything and updating it so everything is using, modern components and like changing. It's, a lot of it's like, oh, just like a diode or like an LED or um, uh, a regulator or whatever. Some are a little bit more advanced revisions. The easy ones are mostly just to like kind of unify like the way we process like components, and so making it so like basically the next time there is a chip short, like I lived through like, oh, like a chip shortage would never last more than a couple weeks. Remember like the one in 2008 that was a full like 2 months. But having learned from 2021, 2022, and a little bit of 2023 is the way I categorize components to make it more general purpose. So it's like, instead of like being specific about like the BSS diode, your dual um, N channel FET, that I use for level shifting. I have like a class that I can use, and so just going through and classifying all that. Anyways, it's a lot of busy work. I'm getting through it, but I'm also getting through some of the more serious revisions because components got like fully discontinued. So one of those is the Clue. I really love this board. This was one of our AdaBox boards. It's been out of stock for like easily over a year. Because and it was one of the last products we did before 20, like mid 2020, when like we couldn't do a lot of manufacturing easily, and we were focusing on making, face masks and medical devices. And so the Clue, by the time we were up and running and like, okay, let's like make some more, a lot of the components on the back were no longer available, and they were not available for quite a long time. So, in specific, the gyro accelerometer got completely discontinued, and then the BMP 280 was kind of unavailable. I couldn't get microphones, and the magnetometer was also extremely unavailable. I actually ended up redesigning this a little bit to use a different magnetometer, but then the magnetometer kind of came back into stock, and so I was like, well, I rather like this one, and the pricing was reasonable again. So I wanted to get this back stocked. So if we go to the overhead, can show. Uh, okay, so this is the prototype, which is green. And you can see here, this is the test program, which is, you can see test, it says test okay. Uh, this is the default test. Oops. There you go. So just verifying that all the components are okay. So I used to use this LSM6DS 33, and like I said, that was completely discontinued. So instead, it's now using the LSM6DS3TR, which is a very similar, but unfortunately not pin compatible. It's a different package. So yeah, the board had to be relayed out. And while I was there, I kind of fixed up a couple other little things that have been bothering me. But then because I finally got enough components booked and on site. I ordered them, and so we're gonna get the clues back in stock within like by the end of January, unless something really terrible happens. And then I've also got the Feather Sense, which is also a very popular board, and it's actually almost all the sensors that are on the Clue, except instead of on the back, they're kind of on the top here. It's a single-sided design, inspired by the Arduino. I don't remember it's like the Nano Sense. I don't know. They made an NR52840 board with also with sensors on it, and I was like, that's a really good idea. Plus, there was like 5 billion Kickstarters that were like, here's Bluetooth with an accelerometer. So it had like PDM microphone, gyro, accelerometer, magnetometer, APDS 9660, which was also, by the way, discontinued, but I got enough in a last time buy that I'm comfortable for a few years. SHT, humidity sensor, BMP 280, barometric pressure sensor, NeoPixel, you can see there's a user switch, and then I mentioned the PDM mic, and the NRF52840 module. So this also got redesigned. Now it's good to go. There's no display, so it's not as fun to show off the demo. But all the components have been tested. And the nice thing about the accelerometer gyro that I picked is that it's part of the same family of chips, and so the library is actually very, very similar. It's like the ID code is different. And I'll show it a little bit for the great search when I get to it. I'll talk about like what is the difference between this family. I think I figured it out. Basically, it's just the quality of the gyroscope. So that's happening. So I'm really excited because those and then the Pi TFTs are like the final things that we're like unable to get, and the bag tag because the e-ink display got discontinued, and then I couldn't get it, and I got it, and something it didn't work. Trying to find a 4-channel grayscale e-ink display was a little unpleasant. Um, but I feel like it's well within Q1 of this year. Every single product that was like discontinued or suffered under the part shortage will be back in stock. I also did a couple of new designs. So since I redid the Feather Sense, I revisited. So this is a design I did like in like mid 2020. Also, again, I took the Feather Sense and I did those Feather ESP32S2 TFT boards, and I was like, oh, I kind of like it. Let's make a version with the NRF52840. So it's got, the 2 buttons on the top and a STEM QT port, and battery, and then a 240 by 135 TFT IPS display, and all your favorite sensors on the bottom. I finally had them, and then I bumped up the flash to be 8 MB of flash instead of 2 MB. So this would be kind of good for like data logging and stuff. Um, Still working on this. It's not quite working. It does enumerate, but the display doesn't show any. It lights up, but it doesn't work. And I don't know. But probably by next week I'll show this off because I thought it'd be fun. It'd be like a little mini clue because you can then show the sensor data on the display. I think this could be a really nice little board. But like, it's so sad. I have a huge pile of like stuff I designed in like early mid 2020 that like by the time I was ready to like manufacture it, I could not. So this is coming soon. And then over the Christmas break, I was just really bored one morning somehow, and I designed a can BFF for Cutie Pie boards. So this is a CAN bus board. And so some of the cutie pies, they use like the ESP32, and that does have built-in CAN, but then you need a transceiver. And also, like, the CAN interface isn't as well documented and, like, I don't want to say maintained, but like a lot of people know the MCP2515, which is basically this chip is the MCP2515 plus a transceiver in one. It's like if you open this up, it's probably the two chips are inside and they just like bond them together. So you can see it's got the crystal, the chip. This is the termination resistor, and then the termination resistor jumper, and the little protective, Zener diode thingy, whatever they're called. And then this is a connector. You can see ground, high, and low. So these are the 3 pins that come out of here. So it's you just plug in wires, so it's nice and flat on the bottom. And then I thought I'd show another thing I worked on is I've been doing, well, I'll show it really fast on the overhead before I go to the computer. You said it. So I've been, I'm always doing work with AT Tiny chips, and they use UPDI. And I made a little UPDI programmer by taking, a CP2104. And then I just connected a 1K resistor between RX and TX. And then this is like the little wire that comes out of the TX pin, the RX pin. And then you power the device from, I made a little stomach QT dongle connector that just gives it 3 volts from here. But this is kind of annoying. I mean, it works, but I would prefer to have like a little slightly more elegant system. Also, I want to be able to select 3 or 5 volt logic and power. And so, and also, once in a while, I may want to use high voltage. So, one thing that's kind of neat about UPDI is I'll show. We have a board here that has a so like just this random board I've got. So this board, you have one pin that's used for UPDI, the programming interface, but that can also be used as reset. There's no like usually there's no separate reset pin, but if you do want a reset pin, you can use the reset pin, the programming pin as a reset pin. However, if you do that, then you need to use a high voltage pulse to activate programming mode. So like the pin has to go up to 12 volts for like for 10 milliseconds, 100 milliseconds, and then back down, and that tells the chip like, okay, expect programming commands next. Because otherwise, the reset button, because it's a mechanical switch, it could debounce and it could accidentally send the signal that would tell it to like erase the entire chip. I mean, you think it's unlikely, but then you deal with electronics, and if you have enough bounces and enough switches, eventually the command will be sent over to erase a chip. So I designed a high voltage UPDI programmer. So you go to the overhead. I'll show this. That's the computer. Um, and then we'll go to the great search. So this is my design. And I grabbed this from, I should have pulled it up. The reason I found this is because when I was doing research for the INMPI, I was like, oh, like, let me look up, like, is there such a thing as a UPDI programmer? And I found this really great collection of open source UPDI programmers, and this person designed a really nice one under a Creative Commons license, and like I'm totally crediting them because I totally ganked a whole bunch of ideas. So they have this little boost converter. I did a couple things a little differently, but they do have a really nice graphic showing the pulse. So you see you pulse it high, and then you can send the data commands. Um, so this design is very similar to theirs, except I use USB-C over here. Same regulator because it's the same regulator I use. And then a mechanical switch to select between VBus, which is 5 volts, and 3 volts. So, 5 volt and 3 volt power and logic. They were using the CH340E, which I've never used, but I've used similar chips during the part shortage. I couldn't get Scilab's chips. I used CH9102. So the 340 is, a very popular series of very low cost USB UART bridges. So I know they're well established. I've got the resistor here, and then TNW. It seems like this can also be used as an activity LED, which I really like. I really like having an activity LED because a common issue I see all the time with folks is they don't have the right COM port selected. Like they think they do, but they don't. And so I'm always like, do you see the TX LED blinking? And they're like, no. And I'm like, then you're not sending data. You think you're sending data, but you're not. And then this little booster that gives 12 volts. I'm also using the same chip they're using. I've never used this MT3608. Originally, I was using the TPS 61229, I think is the part I used. But I thought, like, try this part. Why not? It's like a low cost, simple 12 volt booster. The only thing I did a little differently than them is they use a kind of a cool like diode selection matrix thing to determine when to enable 12 volts. But I really wanted to kind of have it more electrically separated. And so I have this RTS thing is kind of interesting. I'll talk about in a second. So the comment is the UPDI output, and then you can see normally connected is 12 volts. That's on purpose. And then normally open is the RxD pin, and then you can basically switch. Do you want it to have the UART data, or do you want it to have the 12 volt pulse? And then the signal is how you do it. And then very similar to how Arduino uses the RTS pin or the DTR pin to toggle the reset before upload. That's how it does the auto reset. This does it's basically the same thing. That pulse from RTS, when you open the port for the UART, it almost always drops the RTS line low. When that happens, it will drop VDD/IO from the logic level down to ground really quickly, and that will select the 12 volt, and then it will slowly charge up again through VDDIO, and then we'll go back to selecting the UART data. So, again, I borrowed it from this other person's design, which seems really good. I'll try it out. They had slightly different values here, but I can always like solder in different components pretty quickly. But ideally, then, with this, it's a transparent thing where, the RTS pin can be toggled by either the UPDI programming software or just by the port. It will automatically say like, okay, I want you to enter into programming mode. So we'll try it out. The only thing that's a little down about this is you always risk having a 12-volt line going on to here. So just make sure that your device is actually okay. You can't program anything else with it. And is there any other issues? Yeah, you always have to you always will enter into programming mode when you start. Maybe you don't for some reason. Maybe like you want to get the debug data out. I don't know. Anyways, so that's my little friend here. And then I put a JCSH connector so I could have a cable dongle with wires because this cable dongle thing is a little annoying. So the designs that I worked on over the holiday break, and we'll be getting back into all sorts of stuff. I'm again still doing revisions, but I'm up to 610 out of 630 total. So I have 20 more to go, and I do like on average one a day. So a couple weeks I'll be done. All right.
All right, before we go to the great search, can you go to AdaBox.com?
Oh yeah.
Just want to do a quick update. We do updates everywhere all the time, but we're going to keep doing them. So over on AdaBox.com,
Yeah.
you can check it out. It's also adafruit.com/AdaBox if you want to go directly to it. We did an update on December 19th where we said we're getting out some AdaBoxes. We wanted to get some out by the end of 2023. We did. Some folks have it. You can watch the video from our show. And we'll be able to get more out. We're just getting the rest of the parts. So we'll catch up to AdaBox 21 first quarter, then hopefully be on schedule for the rest of the year. We're not emailing or letting anyone know unless we're ready to ship their AdaBox, so you have plenty of time. However, it's always a good idea to go in, log in, make sure your shipping information, payment information, we don't charge until we ship. We'll keep doing updates and more. Thanks for your patience. And if this is too much for you to wait, no problem. Cancel your place because we have thousands of people want AdaBox, so totally okay, no hard feelings. People want in, so we're totally cool with it. We're gonna open it up to more later, but once you're out, you'd have to sign up again to be notified when we have slots open. So, anyways, on to the great search.
On to the great search.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. Thank you, DigiKey, for making this happen every single week. Ladyada uses the power of engineering to help you. Yes, you find the things that you need on digikey.com. Searching for parts is an art. It's a skill. It's a thing. Ladyada, what are you looking for this week?
Okay, so one thing I did this week is I've been trying to get some of these boards that have like very discontinued, unavailable part shortage things on there, and the Feather Sense was one of the ones that was really challenging because it had so many sensors on it, and all of them were from different companies, and they were all unavailable. But a lot of them came back into availability recently. I wanted to get this design back into the shop, and so the part that was, and even on the Great Search, we actually covered like getting the list 3MDL, getting a replacement, and some other components and crystals and neopixels. The part that I want to try to replace today is this one. So this was the LSM LSM 6DS33, which is a IMU. It's a triple axis accelerometer gyroscope. And this is obsolete and no longer manufactured. And they recommend, DigiKey recommends a alternative, but it's always good to like search on your own just in case if there's something you want that's a little bit different. So, sorry, I was zoomed in so much. Obsolete, totally unavailable. So gyro accelerometer. So the only thing is with this gyro accelerometer is like I know just because if you go to LSM 6DS33, I mean I used to stock it. So let's look at the discontinued ones. I discontinued. So this was a 16G, 2 to 16G, and 125 to 2000 DPS. I squared C or SPI. I only really used I squared C, to be honest. And then like, you know, double tap, detection, free fall. But it was very basic. To be honest, it's a very basic IMU because the Feather Sense and the Clue wasn't meant to be like a commercial drone or, you know, VR helmet type thing. It was like, I just kind of want to do some basic sensing of location. So I went with a very inexpensive sensor. So like I said, we searched for 9 DOF IMU replacements and magnetometer replacements. The suggestion here is the LSM60SO, but let's see, there might be other options. So what we want is, well, let's just go to IMUs and we'll just search because we don't want ST. So let's go to stacking. Okay, so we're gonna look for active. Important because I'm not going to do that again. And then I want surface mount, so I'm just gonna skip over chassis mount. Normally stocking, which already cuts out because again, so many chips were discontinued. And then what do I want? Barometric pressure sensor? No, but that's kind of nuts that they have that built in. Accelerometer and gyroscope. And I don't want with a magnetometer that's a 9 DOF. I want a 6 DOF. Accelerometer, gyroscope. With or without temperature. I don't want a magnetometer. I want it to have I squared C and SPI. Some have I3C as well. Good for them. Looks like we've got 31 options. Okay, so Bosch, ST, TDK, and Worth. Like totally what we expected. So there is a bunch of that, you know, that one that they suggested, the LSM 60SO TSR. And so I was like, well, let's just sort by price. And there's a couple of options. What's nice is that the prices are like reasonable again. Like, having seen for like a while there, it was like $100 for like a 6 DOF sensor. It was kind of nuts. They're back down to $2. So the question is, which do I want? So I'm, you know, I'll say honestly, in this particular case, because I'm replacing an existing component and the component is the LSM60S family, I'm going to go with that same family. If I was starting over with a new design, I might be like, hey, you know what, let's change and go with a Bosch sensor. But I'm a little bit like, I'm already doing enough work. I want to replace it with something that's the same family. So I picked ST to pick only the ST components. So now the only thing is I'm a little like I actually was like, wait, there's the 6DSM TR. TR means tape and reel, so you can actually kind of ignore the TR part. There's the LSM 6DSM, DSL, DSO, DSR, DSO32, DSV for very nice magnetometer. I don't know. And then I was kind of like, there's way too many of these. I need help to know. And then the DSRX. So you know, I sorted these by price. So in general, it's probably going to be lower quality or higher quality. And what is nice is I'll say, you know, I'm going to get it. Just I've already did this research. They're all pin compatible. They all use the exact same pin out. Thankfully, ST picked. They picked this like 2x3 like rectangular shape, and they put the pins always in the same locations. They did that after the DS33. So all of these are going to be pin compatible. So, you know, I could swap between them, but I want to pick one if I can. So, you know, I was kind of Googling to try to figure out what the deal is. I'll be honest, a little unclear. Some of them are a little, you know, they explain like, okay, this one is designed for camera stabilization. Not that it matters. So let's go to, I'll show you how I kind of like figured out what's up. So I go to the inertial module, which is the entire family, and this is on the st.com website. And then there's like a bazillion pop-ups. And then product selector. I'm going to shrink this down. Okay. Product selector, and then what I did is I was like, well, I know that the angular rate I wanted to have was, you know, to 2000. Because remember, that was at the bottom here. I only need up to 2000. You're going to pay for more and more, so I don't want it to be more than 2000. And the accelerometer, I don't want it to be more than 16. And so I think this filtered it. So now I only have 12 options. And you do see like DSM, DSO, DSL. So then I kind of looking at the table, I was like, well, what's, oh my God, it's like, and unending toast. There is some power mode changes, but the real thing that you're going to spend, and I'll tell you another thing, you can't sort by price here. What you can do is sort by noise density. And that's actually going to be the same as the price. Because the thing that is what makes these accelerometer gyros expensive. First off, accelerometers cost like nothing. Accelerometers are very inexpensive for the most part. This has been figured out. MEMS accelerometers. Not that there's some that are a little bit better. They might have better filtering, but the technology is kind of well established and the quality is kind of well established. Gyroscopes, what you're going to deal with is noisiness and drift, because that's the thing that's going to introduce the most error into your calculations when you're doing like 9DOF, attitude calculations or absolute orientation calculations. And so the higher the noise density, like the more you're going to see like wiggle and drift as things like start kind of moving when they should be moving, even when they're still. And you can tell, and I know, for example, for a fact that the DS3TR is the least expensive of all these. Not surprising, it's going to have the highest noise density. And then the lower, the ISM series, we stock this one. It's a very, very nice accelerometer gyro. It's going to be lower. It's like, significantly lower. It's like 30% less than the DS3TR. And then from then on, it's like the DSL is next and the M is next. So, although they're very similar, they only go down by like 5 each one. The DSO and the DSOX, which we stock, they're kind of nice down at 70. But you start paying much, much more. Like the price increase, even though it goes down only by 5 micro G for square root hertz, it is going to be it's going to be significantly more expensive. And so I want to get the 3TR, the DSL, or the SM. And then if you go back down here, you see, yes, the SM and the SL are basically the same price. The SM is actually a little bit less expensive. And that's actually kind of nice because it also is a little bit higher quality. If you see here, it's 75 instead of 80, but otherwise it's the same power and the same current consumption. So I think the M, which they have 40,000 stock, is the winner. This is a nice one. About $2 in quantity. The board does need to be redesigned to handle this new 2x3 pinout. But here's the good news. On the off chance that the M is suddenly unavailable, I can swap to the L. It's a firmware change only. And then, maybe you don't promise more than the L model performance. And then they get the M, then it's higher quality and a little less expensive. So this is my pick for the Great Search.
That's the Great Search.
Where in the world is that part I need? The Great Search with DigiKey.
All right, and that's our show for tonight. Thanks so much for stopping by, everybody. We'll be doing our shows throughout the week. We've been back to publishing every single day, something unique, weird, new, behind the scenes. So look for that. And
Yeah, I'm designing stuff, sending it to Phil. Phil posts
it's
it.
happening.
So you can see like what I'm up to.
It's happening. And then thank you once again for all your patience with AdaBox. We are shipping some of them, and we'll continue to provide updates when we have updates.
All right, thanks everybody.
See you all soon.
Have a great weekend. Well, a great weekend. A great week. The weekend's over. How the hell?